Hello, 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 folks. Root Beer here with question number 20 on the 2017 Cayley contest. So once again, I'd like to remind you, if you want to, download a copy of this contest, try question 20 out, but especially because we're going to be moving into Part C, try those last 5 hard questions before I get to them and see how far you would get, which ones you get, which ones you had to guess on, which ones you just didn't quite understand. Okay? Practice does make perfect. So, question 20 here, we'll finish up part B. Car X and car Y are traveling in the same direction in 2 different lanes on a long straight highway. Car X is traveling at a constant speed of 90 kilometers per hour and has a length of 5 meters. Ooh, okay, so already I'm a little suspicious of 5 meters, 90 kilometers. I feel like we're going to have to be converting units, and that might be something that causes some problems. Car Y is traveling at a constant speed of 91 kilometers per hour and has a length of 6 meters, or 0.006 kilometers, because there are 1,000 meters in a kilometer. Car Y starts behind car X and eventually passes car X. The length of time between the instant when the front of car Y is lined up with the back of car X and the instant when the back of car Y is lined up with the front of car X is t seconds. The value of t is. Okay, let's draw a picture of the 2 scenarios. So we care about 2 particular times, and we want the difference between them. So we have car Y a little longer than car X, and we care about this moment in time. So we'll assume that they start off like this. And then eventually we're going to have car X, but now car Y has just barely passed. Okay? So, that's what we've got going on there. We want the time it takes for this to happen. The time it takes for Y to overtake X. Now, by how much has it overtaken X? So, if we imagine we're driving and we're X here, so we're X in our little picture. We're sitting in X, and if we imagine we're driving, things aren't moving. Okay, we're driving, obviously trees whizzing by, but relative to us, we feel like we're stable, we're stationary, and it's the world that's whizzing past back in that direction at 90 kilometers per hour. So I look out in my blind spot and I see, Y is gaining on me. Y is going faster, but to me, it doesn't seem like he's going 91 kilometers per hour. It seems like he's just slowly gaining on me at the difference of our speeds, because we're heading in the same direction. So he's only really going 1 kilometer per hour faster than me. So to me, it looks like he's going slowly creeping up on me at 1 kilometer per hour. Okay? So that's what we've drawn in our pictures here. X he's in the same position, so this is all relative to what X sees. So Y starts back here, at the very back of X, and the front part of Y is what we keep track of to tell how far we've gone. So he's gone 5 and then 6, so 11 meters forward relative to car X. That's how far we've gone. I'm just going to double check. They're traveling in the same direction, 2 lanes. Okay, there we go. Everything's fine. I was worried for a second that they were traveling in opposite directions, but of course, we wouldn't have the front of car Y lined up with the back of car X, and the back of car Y lined up with the front of car X if they were traveling opposite directions. Actually, no, I suppose you could have, but it doesn't matter because they are traveling the same direction. Okay? So, relative to X, car Y in this particular, in time t, moves forward 11 meters. Okay. Also, relative to car X, car Y is moving at 1 kilometer per hour. Okay. The difference of their 2 speeds. Car Y is moving faster, but it doesn't look like he's moving 91 kilometers per hour. It looks like he's just gaining slowly at 1 kilometer per hour. So understanding how their speeds are relative and how the distance that y makes up is relative to what the guy in x sees helps us figure out this question. So in t seconds, which again, I don't like that we're switching units here, but in t seconds, car y moves relative to x by 11 meters. Okay. Now I'm going to change. So we understand we have the distance we want. We have the speed here. We just want t. So t is the time, and that's distance over speed. So t is the time to go 11 meters going at 1 kilometer per hour. Well, the units don't match up. Okay. 11 meters at 1,000 meters per hour. Okay. So now we can, it's 11 over 1,000. The meters cancel out and we get hours on top. But t is in seconds. Okay, well, multiply by how many seconds in an hour? So 3,600 seconds per hour. That all cancels. 2 of the zeros will cancel here. So it'll be 396 over 10 seconds, and that'll be 39.6 seconds, and I think that should be our answer. And 39.6 is one of the possibilities, so that's what we're going with. A. Okay, and that wraps up question number 20. This was very conceptual. Not only did we have to convert through units, which I totally called was going to be annoying, but we had to sort of stop and think, okay, how do I set this question up? And the easiest thing to do when you have people moving together or moving opposite each other is just say, okay, one guy is fixed. And now the other guy is moving at either the sum of their two speeds, if they're moving in the same direction, or sorry, if they're moving in opposite directions, or the difference of their speeds if they're moving in the same direction. Okay, and I tend to pick the slowest person from my perspective. That way everyone's still moving in the same direction and everything. Yeah, wow, okay, so that was I think that was a good question 20 considering the other questions we saw before it. I'd say that was a good question 20 and makes me excited to see 21, 22, really all of part C. And we're going to get into that in the next 5 videos. So I once again would like to encourage you, try those questions if you haven't already. And in general, because I like occasionally promoting, feel free to like or subscribe or any of those fun things. But even if you don't, I'll still be here for more math, and I will see you guys next time. Thanks for watching.